This meeting is being recorded.
Good afternoon, students. Welcome to our today's class. Our units, we are still talking about minerals and rocks in geography. But today we're going to talk about mineral identification, which is our topic 2. In our last class, we talked about the definition of minerals and rocks. We talked about the characteristics of minerals, and we talked about the types of minerals. So today we are going to talk about the mineral. Mineral identification, it's a way of identifying minerals using their properties like color, luster, hardness, and cleavage. Let's study. Mineral identification is the identifying of minerals in a fundamental scale that can be a complex process involving various properties and tests. We have different ways in which one can identify minerals, and one is color. While color can be a helpful initial clue, it's not a definitive indicator of a mineral's identity, since many minerals come in various colors due to impurities. Therefore, color should be used in a conjunction with other identification, though it might be an initial clue to identify minerals. Another way to identify minerals is by streak. The streak is the color of the powdered form of a mineral. It's determined by rubbing the mineral on an angularized porcelain plate. And we see the streak can be more consistent and diagnostic than the mineral external color. So looking at the color, looking at the streak, you can be able to differentiate each mineral. Is it gold? Is it diamond? Is it copper? Is it aluminium? One can be able to differentiate. And another way to identify minerals is luster. Luster refers to how a mineral reflects light. We found that common lusters include metallic, vitreous glassy, pearly, and others are dark. This property helps to distinguish between minerals like pyrite and quartz. We find that pyrite is a metallic luster, while quartz is a vitreous luster. Through using a luster, you can be able to identify which kind of mineral is this. Is it pyrite? Is it quartz? Another way to identify mineral is by looking at its degree of hardness. Even the more scales of hardness ranks mineral from first to 10th scale, whereby the first one is the softest, metallic, and the 10th is the hardest, like diamond. You can scratch a mineral with non-hardness against a non-mineral to determine its relative hardness. Another way is by cleavage and fracture. Cleavage is the tendency of a mineral to break along specific planes, producing a flat, smooth surface. And fracture is the way a mineral breaks when it does not exhibit cleavage. These characteristics are useful for distinguishing minerals like mica and quartz. Whereby we find that mica, it has a perfect cleavage, like it's perfect. And quartz, it has a conchoidal fracture. I don't know how I can explain it, but you can understand it. Conchoidal fracture. This one, like mica, it has a perfect cleavage. I think you understand the meaning of cleavage. Well, quartz, it has a conchoidal fracture, like it has a fracture somewhere. Through looking at the cleavage and fracture, you can be able to determine which type of mineral is this. Another way to identify mineral is by cristoform. Some minerals exhibit distinct cristoforms or shapes. Find these shapes such as a cubic shape for halite or hexagonals for quartz can help to determine the mineral. So this mineral can be a cubic can be hexagonal, can be triangular, rectangle. So through looking this crystal form, you can be able to determine. Like most we see diamond is like in a triangular shape. We see halite is in a form of a cubic shape. We see that quartz is in a form of a hexagonal shape. And another way to determine mineral, let's look at the specific gravity. Specific gravity is the ratio of a mineral weight to the weight of the equal volume of water. And found that this property can provide valuable information for mineral identification. Another way to identify is by acid reaction. Some minerals react with acid bubbling. In chemistry, it's called effervescence, something like that. Yeah, effervescence. So some minerals, they can react to acid, producing those bubbling. For example, there's this mineral called calcite fizzes. There's this mineral which is called calcite, and it fizzes in the presence of dilute hydrochloric acid. Sorry. We have magnetism. A few minerals like magnetite exhibit magnetic properties, and they are attracted to a magnet. And this can be a useful diagram. So if you have a magnet and you have magnetite as a mineral, or you have copper, you have, let's say you have, which mineral? Let's say you have as asbestos. You have asbestos and you have gypsum, and you have the magnetite. So if you have that magnet, if you use that magnet, you'll be able to identify which mineral is a magnetite and which one is not. Let's look at the taste and smell. Some minerals like halite or salt and sulfur have distinctive taste and odors, which can aid in identification. So like halite, it's salt. You can say it like that. Another way to identify minerals is by tenacity. Tenacity describes a mineral resistance or bending or being crushed. For example, we have malleability. In chemistry, we are taught, but malleability is the ability to be hammered into sheets, hammer being elastic. So through using that tenacity, you'll be able to identify which mineral can be able to be hammered into sheets, can be able to bend, can be able to be crushed. Let's look at the other way to identify is by double refraction. Certain minerals like calcite exhibit double refraction, causing objects viewed through them to appear doubled, and this property is unique and diagnostic. Another way to identify different minerals by optical property exhibits specific optical property like birefringence and calcite, which can be identified using a polarizing microscope. Another way is by density. Measuring the density of a mineral can be another valuable clue for identification. For example, we have common minerals like quartzite and gypsum and copper. Quartzite is one of the most abundant minerals on Earth. And it's like, it comes in various colors and have a glassy luster. And it's known for its hardness, lack of cleavage, and conchoidal fracture. And gypsum is a sulfate mineral that it's soft. It's often used in the production of plaster and drywall. Another way, copper. Copper is a native copper. It's an elemental mineral that occurs in a pure form. And we found that this copper is known for its distinctive copper color and malleability. I said malleability means this copper can be able to be hammered into sheets. And that marks the end of our today's lesson. We have learned about different ways in which one can identify mineral. Can use color, tenacity, density, double refraction, and others. Let's meet on another class. Have a nice time. Bye.